Alright, in this video we're going to talk about how we graph compound inequalities. What is a compound inequality? A compound inequality is a group of two individual inequalities connected with either an or an and. We see a few examples here. We've got x is greater than 4 or x is less than negative 2. That's an or inequality. And we see x is greater than or equal to negative 1 and x is less than or equal to 2. That's an and inequality. And then we see this third one, what I frequently call a string inequality, where we've got our variable x and we actually have two inequality symbols. Anytime you see one like this is an and inequality. It actually represents these two inequalities. Negative 3 is less than x, and x is less than or equal to 6. So if we think about this, we can flip this first inequality into normal variable on the left-hand side. And what that inequality means is it means x is greater than negative 3 and x is less than or equal to 6. When we talk about graphing compound inequalities, it depends on whether they are an or an and inequality, how we graph them. Whenever we have an and inequality, we're looking for all the values where both of the individual inequalities are true. And whenever we have an or inequality, we're looking for where either of the inequalities is true. All right, let's look at a few examples. Part A, graph x is less than 2 or x is greater than or equal to 6. Now, something that I started doing when I was much younger was I kind of thought about how these worked out, and I would think, okay, x is less than 2 looks like this, and x is greater than or equal to 6 looks like this. Since this is an or inequality, I want where either of these is happening, and so if you kind of go down through and highlight through here, one of the inequalities is true everywhere in there up until this open boundary, and then in between these two there's neither of them are true, and then one of them is true all the way over here. And so since this is an or, we're graphing where either of them are true, and so we want all those values and we want all of those values as well. And there's our graph of x is less than 2 or x is greater than or equal to 6. Let's look at the next one. X is greater than or equal to negative 2, which looks like this. And x is less than or equal to 5, which looks like this. Now in this graph, we only want where both of them are true, since it's an and so both of them are true right here, and they're both true everywhere in here, all the way over to this boundary. And once we get past that point, then we're back to the stage where only one of them is true. And so we want all the values starting there, ending there, and everything in between. And that's the graph of x is greater than or equal to negative 2 and x is less than or equal to 5. Remember that this one represents x is greater than or equal to negative 4 and x is less than 3. And so there's x is greater than or equal to negative 4. There's x is less than 3. We want wherever both of them are true, which happens all the way over to this open circle. And at that open circle, only one of them is true. But that open circle forms the boundary. So we want an open circle there, closed circle there, and we're going to shade wherever both of them are true, which is right there. Then x is greater than or equal to 7. Looks like this. X is less than negative 4. Looks like this. This is an or inequality, so we want wherever one of them is true. One of them is true everywhere there. One of them is true everywhere there. So we want both of those segments on our graph. And there's the graph of x is greater than or equal to 7, or x is less than -4. A few tricky examples on the end here. X is less than 7, or x is greater than or equal to -2. There's x is less than 7. Here's x is greater than or equal to -2. And what makes this different, this is an or. So we want to graph anywhere where one of these inequalities is true. So all over here, one of them is true. In fact, both of them are true. But over here, one of them is true as well. And if you think about it, at least one of those inequalities is true for every number on the number line. And so that one would end up being the entire number line. Every single number that exists is either less than 7 or greater than -2. All right, and the last example here, x is greater than 5. Looks like this. X is less than or equal to -2. Looks like this. Now this is an and so we want all the places where both of those inequalities are true. And you can see from this little sketch here, there's nowhere where both of them are true. And so our graph of the solution for this inequality will just end up being a blank number line. And so there you go. That's a review of all the possible things that can happen to us or for us while we're graphing compound inequalities. That concludes this video, and we'll see you next time.